Okay, so yeah, I'll hand it over to you guys, and I'll let you guys introduce yourself. Jeyler and Tony, I don't want to mispronounce your last name either here, but thanks everyone for joining. Tessco has offered to host some DAS training for us here today, and with that, I'll hand it over to Tony and Jeyler to kick things off.
Thank you, Matt. First and foremost, appreciate everybody's time this morning, especially blocking out this type of a chunk of time for training. I know your time is valuable, so we hope to make this worthwhile for you. Please excuse my voice this morning. I'm a little under the weather, but my name's Tony Biglieri, for those that I haven't met yet. I'm a key account manager here at Tessco. I handle mainly the Pacific Northwest, but I also handle national accounts to some degree, which is my interaction with border states. Tessco, for those of you who are unfamiliar, is a wireless distributor. We try to be a one-stop shop, is how I like to put it. We can handle the entire BOM from cable to towers, through the active equipment, the actual DAS BDAs or microwave radios. We have over 250 different manufacturers, and at any given time, 30 to 40,000 different products that we offer. So we'd like to be your one-stop shop. We can help with design work and put together the entire BOM, and fulfill that and deliver it all in one box pallet, however we do it. So that's the 30-second Tessco pitch there. I'll go ahead and turn over to Jeyler and let him introduce himself, and then we'll dig right into this so that we can get through the presentation and get to any questions that you may have.
Yep, and thank you, Tony, and thanks everybody for being here. My name is Jeyler Zabala. I am the DAS Solutions engineer. I've been with Tessco for about 6 years. I'm an electronics engineer, RF engineer. Worked for a BDA manufacturer in my former job, and been doing this designing IB wave design, ROM bombs for most of our customers for the past 6 years. And with that, the presentation today is going to revolve around RF best practices for public safety DAS, and why it's important, and how did it came about, and what are the codes, regulations, and best practices for it. So why is public safety DAS important? Well, basically it ensures that first responders have access to reliable communication with adequate in-building signal coverage that is transmitted throughout the building in the event of an emergency. Back in the 9/11, after all the commissions do the review on what happens and why most accidents happen in the event of fires and shootings and stuff like that, always the lack of communication or the failure of communication, it's one of the components that make those reports, right? So after that, a lot of ASJs, counties, communication, first responders came together and said, we got to fix it. Buildings are being built differently nowadays, and we have to have means of communication inside of the buildings. And just like we have fire sprinklers and other kinds of life safety features in buildings nowadays, well, public safety is one of those. And basically what we're trying to achieve here is for the first responders to have good communication inside so that they can perform their job and their duties and communicate with each other in an accurate and an easy way to do so. Now, the problem with that is that each state has their own mandates, right? Each state has their way of following code and how building are constructed. So there's construction codes. So unfortunately, we do not have a federal mandate for public safety. What we have is local and state jurisdictions having to decide how to do it based on the radio networks, and the radio systems are the way they communicate. Most states in the United States will follow building code standards. I think there's only 6 states that don't have a building code standard. And many of those will follow the public safety code will fall into NFPA chapter either 72, 1221 or 1225, or if the state follows the International Fire Code, then they will fall in chapter 510. So it's a very important job that we do. It's basically a life or death situation, and providing good public safety communication is of the utmost importance. What are the components of a solution? Where in the macro side, we have the outside tower, the radios, the ones that the firefighters, police departments use to communicate in the streets. But when it comes to the in-building, basically we have what we call core components and ancillary products, right? So the core components are the BDA, or the active components, if you will. This is a bidirectional amplifier, or the head-end equipment and remotes, and battery backups. And then the ancillary products are the annunciator panel, the donor antennas, the coaxial cable or fiber, whatever medium we use to transport signal, splitters and tappers, distribution antennas, grounding arresters, and anything that is required to properly install those products. And what is a DAS? A distributed antenna system is a network of spatially separated antenna nodes connected to a common source via transport medium that provides wireless service within a geographical area or structure. The antenna node is typically attached to a remote. The signal source in a DAS can be either driven by a direct connection to the base station or the radio station, or it can be fed over the air, or OTA. Basically, that is how we deploy most public safety deployments nowadays, because in order for you to have a direct feed into the BTS, you have to happen to be share the location of where the BTS or the repeater for the LMR system is, and that is those are very few and far in between. So typically, when we refer to signal source, although there can be options when you have a direct feed, it's typically over the air, right? And basically, what we do is we capture signal from the outside, and get it into the BDA, amplify it, and reproduce it towards the inside of the building. And the most common ways of mediums of transporting is either fiber optic, coax cable, Ethernet cable. Nowadays, there's other means that are coming up, but typically we talk about the mediums as being those three: fiber, coax, or Ethernet. Types of DAS, there's typically two types of DAS. And we have what we call the passive DAS, which is basically capturing the signal with a donor antenna, sending it through a bidirectional amplifier or signal booster BDA, and then distributing that signal through antennas that are spatially distributed throughout the building to successfully propagate that signal that is being amplified by signal boosters. I'm going to call it signal boosters BDA. Technically speaking, the term shouldn't be interchangeable, but a lot of people, depending on how old you've been in the industry or whatnot, you're going to hear it BDA, signal booster, head end. You're going to transmitter. You're going to find a lot of people referring in different ways. So, we're going to keep that, but just so you know, a signal booster and a bidirectional amplifier is not exactly the same thing. The active DAS is when we might have a multi-building deployment, or we might have like a college campus where you want to have the signal coming through a central distribution point, and then you have remotes, different buildings, and you want to distribute to different buildings at different power levels and different sizes. So at that point, we consider that a active DAS. Because, like I say, we have a fiber, we have a central point of distribution, and typically you can have up to 16 remotes nowadays, and each remote can handle multiple, into the 50 to 100 antennas. So you will have a lot of signal to be distributed, like a large venue, maybe a huge stadium or something like that will also be considered an active DAS. But a lot of 80% to 85% of our deployments nowadays are single BDAs, small buildings, 3, 4 floors, 5 floors, 10 floors, and you don't require more than either 2 remotes or a single BDA to drive all of those antennas that you require to locate for signal distribution. The public safety frequencies, they pretty much fall into 4 buckets, right? And maybe we want to make the distinction between VHF and UHF. But VHF, UHF being the old way of communicating, typically when at the very beginning, when we had LMR radios and LMR towers, we used to have a lot of VHF, UHF in this country, specifically for the good penetration of the frequency, for the propensity to travel long distances, being able to climb or propagate through mountains and whatnot. That was a preferred frequency. And back then, probably 80s, 90s, whenever Motorola invented their two-way radios. Lately, we have started to switch to what we call a 700, 800 distribution of frequencies. FCC rebranded a bunch of frequencies in that frequency range, and a lot of those frequencies were allocated for public safety. So we have about 70% of all public safety systems in the country right now are running in that frequency. So it's very common for you to find public safety systems in that range, usually dual, sometimes 700 only, sometimes 800 only, but most people that will have channels in the 700 range are going to be asking for licenses in the 800. So it's very common to have or being asked or seeing systems that are 700 now, but 800 in the future. So a lot of times you're going to find that people are going to ask you for frequent, systems in both frequencies. And there's also 900 megahertz. This is very uncommon. Maybe 1% of the systems running this system. One of the most famous ones is like Las Vegas hotels and stuff like that are pretty much private first responders, typically security, towing companies, stuff like that. They are considered public safety. They run in the 900, but it's typically a private system. So those are basically the 4 frequency chunks that we're going to be dealing with. Like I said, probably 25%, 25 to 30% in the VHF, UHF range. If you want me to break that down, typically VHF is about 25% of that 30%, and 75% is going to be UHF. 7800 is about 75% of the time, and then 900, I would say probably a 1% somewhere there. The types of radios that are used, BTS by jurisdiction, it's basically 5, right? So we have simplex systems, conventional repeaters, trunk radio systems, and simulcast radio systems. Those last 2 are basically the last type of technology. It's basically you can have a central location and you can simultaneously transmit at different locations, different messages, and have different central means of communication. Simulcast, the same thing. You simultaneously can send different frequencies and program radios and create talk groups and whatnot into those type of systems. But those are typically the 5 types of radios that we find in public safety. A lot of people, I like to put this slide in all of my presentations, because if you are involved with RF from an old time like I am, you're going to find people calling TX or X, transmission reception. Nowadays, we like to call it downlink and uplink, right? So to make it easy for you, the way we call it is from tower to user or radio. If it's tower to user, we call it downlink, meaning it's coming from up the tower. And whenever we go from radio to tower, we call it uplink. So what happens is, again, the job of a BDA is basically receive the signal, amplify it, rebroadcast it, and the radio is going to receive that signal. And when the people that are using the radios want to talk, they're going to send the signal, receive it by the BDA, amplify it, and send it back to the tower. And that is why we call it a BDA. It's bidirectional amplifier. It's basically the exact same thing, both ways, with a filter in the middle to prevent feedback from happening. Okay. Typically, the DAS hardware is signal booster, the distribution of antennas, the passive to install those antennas, tappers, directional couplers, splitters, power splitters, battery backup, annunciator panel, and nowadays the latest fire code requires you to connect most BDAs into the fire panel. So it's now becoming like an alarm if something is wrong with the BDA. So when the firefighter shows up in any building, he is going to be able to look at the fire panel and say, yep, I'm good with communication. I have enough battery. He's going to have a visual representation of how the communication system is behaving. What what is a BDA? So a lot of people, what does it do? What is it? It's basically a box that is designed to receive and rebroadcast a signal without changing it from the base station. So it's basically a device that automatically receives, amplifies, and retransmit on a bidirectional basis the signals that are received from base stations with no change in frequency or authorized bandwidth. If by any chance you find a device that changes modulation, that shift frequencies, that is not considered a BDA. That will be a base station. That will be a signals modulator or something like that, but it's not going to be considered a bidirectional amplifier. Different names, again, is signal boosters and bidirectional amplifiers. And what does it do is taking an existing signal, amplify it, retransmits it into a space that is receiving or not receiving no signal to extend the radio coverage typically inside of the building. Okay, so again, about 70 to 75% of the public safety systems that we deploy nowadays are going to be consistent with a signal BDA, single BDA, single location, small building or medium-sized building, up to 50 antennas. That is going to be your typical system that you're going to be deploying or working with. The reason why we call it a bidirectional amplifier is, again, it basically does the exact same thing from either the two ports that it has. So it receives a signal, it goes through a small amplifier, it goes to intermediate filters, it goes into a power amplifier and sends it out. And then when it receives from the mobile, it's duplex, small amplifier, intermediate filter, power amplifier, goes back to the tower. So as you can see, it's basically the same thing, the same amplifier in reverse order. So that's why we call it bidirectional amplifier. It basically receives from both sides and it basically amplifies from both sides. And all that magic, it's really thanks to this particular device here. It's called a duplexer, which is nothing more than two filters attached, where you can receive like a traffic cop. So it receives signal and says you got to go to the uplink or you got to go to the downlink, and that's how a signal finds the proper path into either to base or to mobile or uplink and downlink, however you want to call it. Right. There are two types of signal boosters or BDAs as per the FCC Part 90 rules. And we have what we call Class A, narrowband or channelized, and we have Class B or broadband amplifiers. Basically, there is a definition. If you have channels within your BDA that are narrower than 75 kilohertz, you're considered a Class A BDA. If you have channels or amplification chunks that are wider than 75 kilohertz, you're considered a Class B. And with that, I want to make this a little bit interactive. So if you guys have any questions, I can stop and you can ask me questions now. The next part of the presentation is going to go a little bit into the process of getting a public safety system. Then we're going to go a little bit into code. So I'd like to stop here for 5 minutes, 2 minutes. And if you have any questions, please feel free to ask. Okay.
Thank you, Jeyler. It looks like, yeah, we don't have anything in the chat, so I think we're good to go.
Okay. So typically, how does a public safety system comes about? Well, up until 2017, it was starting to be required in new construction, right? Nowadays, in the latest iteration of the code 2021, 2023, depending on where you live, it's being moved onto all existing buildings. But in reality, what we need is new construction. We will need a site survey, meaning firefighters, the police department has to go into your building or should go into your building and say, okay, Mr. Building owner, your building is okay, you don't need a system, or you do need a system, I can't talk there. I'm gonna need you to submit plans and send me the information so you can deploy a public safety system. So there is a plan submittal. There is, within that plan submittal, you have to have a prediction of coverage, meaning you have to be able to produce a plan, give it to the ASJ and say, Mr. ASJ, this is what I intend to do. This is where my antennas are going to go. And this is the coverage that I'm expecting to have based on this initial site survey. As per code, you're only required to deploy a public safety signal if the safety signal exists in the outside of the building. So if you're in the middle of an area that does not have public safety signal, you should not be required to deploy one system in building. That is one of the most important rules. A lot of ASJs don't understand that rule. Sometimes they want to go to a middle of nowhere and say, hey, you don't have signal here. Well, if there is no signal present on the outside, you're legally not required to have signal on the inside. That is one of the, again, very important rule. A lot of ASJs used to miss it back in 2016, 2017, because it was the first part of the chapter. And then when you read through, it seems like every building will need it. But the most important condition is public safety signal has to exist on the outside in order for you to deploy an in-building public safety system. With that, typically you go to your building officials within your city or ASJ. You have to get a permit. As soon as you do that, you go through the deployment process, which is basically installing your cables and your antennas and your BDA and your battery backup. The next step is going to be what we call commissioning, which is basically fine tuning with the ASJ or with the firefighters or the users of the radio system. Hey, give me a little bit more gain, give me a little, I'm a little raspy here, fix my voice, blah, blah, blah. And you typically fine tune that system. There is going to be an inspection done by the ASJ, in terms of building regulation. You have to mount your antennas in, 6x6 boxes or 8x8 boxes. You have to have some fire prevention measures like fire caulking in wall penetrations and stuff like that. The BDA has to be in a 2-hour rated closet. So there is going to be an inspection process for these BDA or for these deployment in general. And once that inspection is successfully approved, then they're going to issue typically what they call a TCO or temporary certificate of occupancy. The ASJ is going to say, yep, I can talk, I'm good. I walk the whole building. I perform the DAQ test or digital audio quality test. And here's your certificate of occupancy. After that, and prior to the building being open for public use, they're going to convert that temporary into a final certificate of occupancy. In this period, you can make some changes, minor changes. If you had issues with, if the ASJ give you a temporary TCO based on, it's all good, but this room needs one more antenna, or, move this box from this room to that room, they're typically going to allow you to do minor changes before they issue the final CO. And after that, as per the law nowadays, every system requires a yearly service. So as soon as they give you TCO, they're going to ask you show me your maintenance contract, just like people do with their sprinkler systems or their fire extinguishers. Somebody has to come in every year and perform some tests to prove and make sure that the system is up and running and behaving the way it's supposed to behave. So who is who does what? Basically, when you hear ASJ, it's the authority having jurisdiction, typically is the radio license holder or their users. Okay, so the radio license holder, ASJ, authority having jurisdiction, in many places could be the firefighting department, police department, building code officials. So it's very important for you to understand that they could be, the license holder might not necessarily be the ASJ. Typically they could be, but they have to designate an authority having jurisdiction within your jurisdiction. So who is going to inspect the deployment? Who is going to do the radio testing? Who is going to tell you what frequencies are going to be rebroadcasted and retransmitted? Those are very, very important details that you have to know before deploying any public safety DAS. Value-added resellers like bars, we'll call bars. These are the people who are going to design, install, deploy, and commission the system, right? So if you have a contractor or if you're a building owner, you're typically going to go to a subcontractor and say, I need a public safety system. Those are what we consider value-added reseller. The general contractor is the guy who oversees the whole construction. They have the subcontractors underneath them. They're going to go in and ensure that they follow the procedure, the code. There is, in some states, there is the requirement that all public safety system designs are signed by a professional engineer. So professional engineers are the guys that are going to typically ensure that the design is up to standards. And usually it's required for you to be an electrical power professional engineer. And sometimes, because we don't have an RF professional engineers, they do electrical with an RF background. Typically, they can require you GROL or some type of license that proves that you have proficiency within RF. Then we have consultants. Typically, owners will hire consultants to make sure that everything is up to code, passes, does it's like an internal inspection to make sure that the process is a little bit smoother. The distribution, like us, is we sell the products. In our case, we're a value-added distributor. We can provide you with engineering support. There is a team like the one that I belong to, where we have professional system engineers, system architects that will come up with the right parts and the right design for the value-added reseller or people who are going to deploy the system. And then the building owner is basically the owner of the building, and they are the ones that are producing the funding. So very important for you to know, if you're in this field, if you're looking for opportunities, there are going to be some requirements. For any public safety deployment, the requirements are going to be, again, local, are going to vary from state to state. So if you are a company that has technicians and people deploying system in different states, you have to be familiar with those. For instance, I live in Florida. Florida has a very different set of standards compared to, say, California. I mean, we do have hurricanes. California, they have fires. So their provisions are slightly different. They all revolve around kind of like the same code, but the frequencies changes, the number of channels changes, the coverage requirement changes, the battery backup time changes. So those are what we consider the system requirements. Again, there could be cities that have UHF, there could be cities that have 7800, and those, believe it or not, are completely different BDAs in terms of how they do the filtering. The most critical part of a BDA is filters. And if you have BDAs in the VHF, UHF frequency range, those are very different from 7800 in price, in size, in behavior, kind of the same thing, but because of the frequencies, the way the frequency behaves is slightly different. And then, of course, you have, as I said before, Class A's or Class B. Installation requirements are they're gonna have requirements about how to run the cable, where to run the cable, how are you gonna protect those cables, how many antennas you should put at what distance, or what we consider the antenna density. How do we protect the elevators or the stairwells? I'll give you a perfect example. If you have a 4-floor building and you want to cover the elevator, you can probably put one antenna in front of the elevator lobby, and that antenna is going to take care of penetrating the shaft of the elevator and have enough signal for them to talk while they are doing their performing their duties. However, when you have a 50-floor building, it's financially difficult to do one antenna in front of each elevator. Typically those buildings, we have multiple elevators, 4, 6, 8, different number. And what it's typically allowed is then to put a Yagi inside of the shaft of the elevator, and you can cover about 10 floors with each. Instead of putting 50 antennas in front of each elevator, you're going to have maybe 5 antennas to cover each elevator bank. So There are different installation requirements. There are different installation procedures that are allowed, and you kind of have to know those before you do that. And with that, I want to take you into what I consider are the 6 most important steps in order to successfully deploy a power safety system. So with that, I'd like to stop a couple of minutes, and if you guys have a question, if not, I'll be glad to continue. Okay, let's go. So the basic 6 steps are: first survey, project design, permit submittal, implementation of the design, optimization, and then final ASJ inspection. There might be some sub steps in there, but typically every system has to go through some form of these 6 steps, right? So what do we consider the first survey? The first survey is the first step, right? Typically, the ASJ is gonna have told you you need a public safety system. So you, as either a contractor or building owner, are going to have to say, okay, let me go to the site and let me see, how do I deploy my system? Where I'm going to locate the system? You know, what chases am I going to use? What kind of signal levels do I have outside? Remember, very important, if I have signal outside and I don't have anything inside, yeah, you need a public safety system. But if you don't have signal outside, you don't need a public safety system. So with that, you're going to make some decisions, sometimes some assumptions. Sometimes the building is not even built, and they're going to say, yeah, you're going to need it. Your building is full of low glass, so we know you're going to need it. And at that point, it's good to plan for it. But if the building is already up and running and you know, they call you to deploy a system, well, you're going to have to find out, where do I put my BDA? Maybe on the electrical closets, or maybe I'm going to put it in the fire control room, or there are different rooms that are allowed. You know, how much signal do I have outside? What is my best location for my donor outside of the building? Is the tower on the north of the building, east of the building, west of the building? So you're going to collect a lot of data. You're going to do a bunch of signal measurements, typically with a spectrum analyzer, and you're going to find out or figure out where is the best place to put most of the stuff that you're going to be deploying. And that all comes down to that. And you're going to get the first survey, you're going to get an RFP document. Sometimes you have to make some assumptions, because you don't know whether this room is going to connect to that other room on the west wing of the building or the north wing of the building. So you're going to assume you can, and you're going to be able to make some assumptions in this first stage that are going to go into the design. But you have to make sure that you tell your customer, Mr. Customer, I'm doing this first survey. I'm assuming this, and I'm assuming you're going to have a penetration in the shaft of the elevator. But if not, we're going to have to figure that out, make a change order, or do something different, right? Then you do the project design, and the project design is going to use the output of the first survey as the input for that design, right? Your designer is going to typically ask, what is your coverage requirement? Do you want to cover 90% of the building, 99% of the building, or 95% of the building, or 80% of the building, but 99% of critical areas? Remember, each code is different. Most standard practices nowadays is you're allowed to cover 90% of the building and 99% of the critical areas. That is typical. But there's some ASJs that are going to say, no, I don't care for any of the building. I care for 99% of critical areas. And typically critical areas in a residential building are going to be your staircases, your elevator, your lobbies, and your where people get together, like public areas, right? But if you're talking a hospital, then what is critical in a hospital? Pretty much everything, right? Except for maybe the docking areas or the loading docks or something like that, where they receive merchandise and whatnot. That is not going to be covered. So depending on the building type and the building form, they're going to tell you what kind of coverage requirement you have. And let's talk about a big mall, for instance. In the event of a shooting or a fire, what is critical? Well, probably the whole mall, because if there's a shooting inside of a mall, people are not going to go to the main corridors. So having communication in the main corridor is not important. You have to have it in the back of the stores. You have to have it in the, loading dock areas. You have to have it in the main lobby. So the coverage requirements are very important. Is probably the most important KPI of any system. Uh, and with that, you're going to be able to come up with a design that has the propagation analysis to show that those KPIs are being covered, right? So again, you're going to have a minimum DAQ level. You're going to have your plans reviewed by the ASJ. The ASJs typically have code in place to make sure that, say, in an event of a fire, active fire, the system stays up for some amount of time. Fire rating or survivability rating is typically 0, 1, or 2 hours. Battery backup times typically is 12 or 24 hours. If you have a generator in the building, you're allowed to have up to 2 hours as a second mean of power, as long as the generator has like an auto start, and you can come up, the system can come up within 5 minutes of the power being out. So again, when you're project designing, you have to account for all of these. At this point, it's recommended that you already clear all of your assumptions from the site survey. Although, again, when you're presenting the plan, if you still have assumptions in place, you should discuss it with the owner and say, hey, Mr. Owner, I'm assuming this is going to happen. If this doesn't happen, we might have to do a change order or whatnot. Once you send the plans to the ASJ, you're going to discuss coverage, antennas in critical areas, stairwells, elevator, pump rooms, fire command centers. Typically, there are rules about enclosures and how to connect antennas, BDAs, and battery backups, and what kind of NEMA rating those enclosures have. How long does the battery backup is going to last? If the ASJ in your area has what we call a fire panel monitoring requirement, how is your connection? What kind of alarms or messages you're going to see? Some people want to have like a visual red or green color LED. Some people want to have like a text on the panel itself. So again, once you review your public safety submittal, you're going to have to comply with all of those requirements that are locally established, and you're going to come up with the best design possible that is going to cover the NFPA rules or the IFC rules that are mandated in your state. Once the implementation time comes, you have to plan it. You have to, sometimes if you're working on a hospital, you might have to work at night. Or if you're working on a mall that is active, you might have to work after store closes. If you're working on a school, you have to work after the school closes. So you have to plan the installation. You have to come up with the best practices for your particular area. So again, I'm going to use Florida as an example. Because we do get hurricanes, the best practice in Florida is the Yagi has to be, the Yagi antenna has to be affixed to a mast with parts that are wind rated up to 175 miles an hour, because we do get hurricanes, right? So if you're probably in the middle of the United States, the wind rated probably is 100 miles, or there's no wind rated whatsoever. So it's a difference. There are differences that are going to come from those best practices. And then sometimes if you're working on a hospital or something, you have to go through an accreditation process or an OSHA safety class or something like that. So when it's time to implement the system, you have to make sure that you plan your installation accordingly and have all the information that you require for that. And at this point, it's very important that there are no more assumptions in your design, because at this point you have to know where the BDA is going to go, how are you going to go from floor to floor, how are you going to go from west wing to the north wing or the east wing, are you going to run fiber in between, are you going to run coax in between? At this point and right before implementation, all of your assumptions have to be clear. You don't, there is no room for assumptions at this point, because if you make a mistake, if you don't have a way to communicate the first floor with the second floor, that's going to be costly at that point, right? Once you do that, you're going to go through the optimization phase. As I said, this is when we are going to commission the system. This is when we're going to compare what we designed the system for versus the actual performance. Everything that we calculate during a design, it's basically an approximation, right? It's a mathematical equation of how the band or the frequency or the signal is going to perform, basically making some mathematical assumptions. If we're talking, say, concrete, we're going to assume that there's going to be a 20 dB there's going to be a 20 dB attenuation of the signal from wall to wall. And those are values that are typically measured, but when you come to real life, you might have 22 dB or 15 dB, depending on how thick that wall is or how much rebar is in the middle of that concrete and things like that. So the deployment and optimization phase basically prove that what you assume mathematically speaking, it's now the right result, right? At this point, you don't have to tell your customers that you're performing optimization, but the ASJ has to know, okay? And the ASJ might require some changes. They might say, okay, you have too much gain in the system. My voice a little raspy, or I sound a little digitized when I talk to my, central location. Lower the gain, increase the power. I don't hear clearly my coworker that is in the staircase, so you might have to deploy more antennas. And in multi-band projects, you might have to equalize. There's some jurisdictions that have like UHF system and 7800 systems. So in those multi-band projects, you might have to do what we call an equalization of signals. So you have to kind of level the UHF with the 7800, so none of those overpower each other and all of the radios can work happily together, right? At that point, if all is good, then you do what we call a final survey, typically with the ASJ. Can you hear me now? Can you hear me now? They're going to walk the whole building. And if they can talk and everything sounds good, they're going to accept it and give you, again, your TCO, right? This typically happens during the optimization process. And then if he asks you today to make minor changes, he's going to come again for a final inspection. The final inspection might be on the optimization, or the optimization can be done by just the technicians or the engineers without the ASJ. But whenever the ASJ is there, then that is what we call the final inspection. And you have to coordinate the acceptance test with the ASJ. You have to, with the ASJ, you're going to perform, voice test. Can you hear me now? Measure RSSI. The ASJ can ask you, show me what is the signal level at this particular antenna. He might review plans. He might, once that's happened, he basically is verifying that the whole in-building solution complies with the whole criteria that the code mandates to do, right? Typically, the ASJ is going to decide, yeah, I'm going to test the elevators. They know that if they see an antenna in a lobby or something, typically, unless there's something wrong with that antenna, they're going to talk. So they're not going to choose to do their test in the obvious areas, right? They're going to choose to do the test in the areas where they think the system has to perform the best, that it doesn't obviously have an antenna rebroadcasting in that particular area. The ASJ can require a UPS or battery backup, and they might want to change it depending on code. I need 12 hours, I need 2 hours. So be prepared for that. Typically, it's stated in the code, but sometimes the ASJ has the ability to change what's written in the code due to particular variations of the code. So clear those out before, and when the final inspection comes, all you have to do is basically comply with all of those. And with that, I'd like to stop, make sure you don't have any questions, and continue after that.
Looks like the chat's still clear, Jeyler.
Okay, let's go. So installation best practices. And what we consider in RF is a famous saying in RF, just enough should be enough, right? We don't want to have RF leaking outside of buildings. We want to kind of, if we want to cover a particular building, we want the signal within that building to be as close to that building only as possible. And for that, we have basically make sure that we follow what we call the RF best practices. And typically, we want to look at antenna isolation. We don't want to put two antennas too close together. We don't want to put the donor antenna close to the indoor antennas. We don't want to put antennas inside of the same room of the BDA. There are delay considerations when it comes to BTSs, when it comes to radio systems. You typically cannot delay the signal being processed because those systems will have what we call a timeout. So if you don't send a response back, they kind of like the cold drop, right? Have you ever been in a situation where you call someone and you don't listen? Well, what's happening is you're violating the response time or the delay consideration of that particular system. And remember, anytime you do a filtering, which is what the BDA does, remember the BDA is receiving signal, amplifying signal, but at some point it's filtering signal. It's filtering the specific voice that is coming from the radio. And if you think of a regular filter, water filter, or any type of filter that you're familiar with, the larger the filter, the slower the filtration process is. So if you have a small filter, you put water and within seconds, you're gonna have water on the other side. But if you have a very large filter, then that filter is gonna do its job and it's gonna take a long time for, say, water, if you're filtering water, to come through at the other side of the filter. So same thing happens with RF. So most systems will have a delay, a maximum amount of delay, meaning there is a maximum amount of filtering you can do in any particular signal. And that is what we call the delay consideration. Then what type of antennas are you going to install? What are the power levels that are required? All of that, it's going to be in the installation best practices. You're going to be able to select the power of the BDA and the BBU size for how many hours of usage you want to have in the event of power not being present in a system. So with antenna isolation, the donor service antenna versus the indoor antennas should be around 20 dB. FCC mandates 20 dB. A lot of jurisdictions allow you to deploy a system with up to 16 dB. And what antenna isolation ensures, and I don't know if you ever seen somebody in a microphone real close to a speaker, whenever the microphone sends signal to the speaker and the speaker and the microphone are real close, the signals create what we call a feedback, or typically people call it a feedback. It's basically the microphone amplifies, sends it to the speaker, and then the amplified signals come back, and that becomes a feedback loop, and that creates problem with any network, right? It's an audio network in the case of a speaker with a microphone. In the event of a radio system, if you're too close and you're amplifying and listening to your own signal, what you create is a lot of noise and nobody typically can talk. So you have to have enough isolation. Typically, you want to have signals from the outside and the inside being 20 dB difference, 16 dB difference, and you have to implement like isolation control techniques in order for preventing that to happen. How do you do that? Well, typically we use a spectrum analyzer. How do you calculate that? It's typically whatever your isolation number, say 20 dB or 16 dB, you have to achieve it above the gain of your system. So if the gain of your system is, say, 80 dB, you have to have at least 96 to 100 dB of isolation in between antennas in order for you, as a rule of thumb, that you're going to ensure that never you're going to have a feedback or feedback loop or any type of problem with deploying that. There is a very typical problem in RF. We call it near far or far end or far end preservation. And what happens is, say an antenna is right above me, and I have a radio, and somebody 100 feet from me also have one radio and is using the same antenna. Typically, when I talk, I'm the closer guy to the antenna. I am going to use all of the power, and the person who is farthest away is not going to be able to talk. So there are techniques for foreign preservation to allow the person far away to listen. One of the easiest one is to deploy antennas every certain amount of distance that allows you to not have that situation. But if not, there are BDAs that will have what we call foreign preservation circuitry that allows you to minimize the gain of my channel and give more gain to the channel of the person who is the farthest away. And that is a very good practice to prevent that, right? So keep that in mind. Is typically you can make sure that you design for foreign preservation or near far effect, and you should typically be able to do it with either deploying more antennas or choosing BDAs that have that kind of circuitry. There is the process of the antenna selection. Typically, the donor's antennas are going to be Yagis. They're going to be directional. They're going to be made for the outdoors, right? They're going to be able to be mounted on a post or a mast or I-beam or affixed to the building. And then the indoor antennas, typically what you want to have is the highest gain. Nowadays, a lot of buildings are architecturally pleasing, or you have to kind of confirm the aesthetics and the mounting options. If you're going to go into hard ceiling or low drop ceilings, or you're going to go into I-beams exposed. So basically make sure you select the right antenna. When it comes to the BDA selection, again, very important that you do your frequencies, VHF, UHF, 7, 800, 900. Usually your gain is going to be between 70 and 90 dB. And again, I don't want to get too technical here, but gain is the ability of the BDA to receive signal. And if you have a very weak signal outside, you definitely want to have a high gain BDA. If you have plenty of good signal outside, then you don't need as high of a gain BDA. So you can vary between typically 70 to 90 dB of gain. The power ranges from about 0.5 watt to 5 watt. If you want me to talk dBs, that's between 24 dB to up to 37 dBs. As of the FCC, the maximum ERP allowed for any BDA is 5 watts. So legally speaking, you shouldn't be able to encounter yourself any BDAs that have more than 5 watt or 37 dBm. And again, oscillation control. For those of you who are designers, technicians, deploying, how many antennas typically can I power with a BDA? If the frequency is VHF, UHF with a 1/4 watt BDA, you should be able to handle between 15 to 25 antennas. We have 8 watt BDA, we have 1/16 of a watt BDA. Anything from 0 to 25, you'll be able to do with a 1/4 watt. Between 25 and 50 antennas, a 1 watt system, and between 50 and 75 antennas, typically a 5 watt BDA. If you need more than that, you are in the master and remote, area where you have one central location and multiple amplifiers throughout. On the 7-800, because that frequency tends to not penetrate as well construction materials, if you need 10 to 15 antennas, that'll be a 0.5 watt. If you need 25 to 40, that'll be a 2 watt system. If you need 40 to 75-ish, it's going to be 5 watt. And then 75 or more, you definitely are going to need multiple remotes to drive that many antennas. Again, your best practices, donor antenna always must be directional. You do not want to put an Omni on any public safety system, because if you are in an area where, say, a large sport venue, typically those stadiums will have every police department come to that building if there is an emergency, right? But your ASJ, your fire department, should have one location. And if you put an Omni, then you're going to be receiving signals for all locations, and that typically is not allowed. You have to have one fire department come, and that fire department is going to call that other fire department in the event of those type of emergencies, right? Depending on the strength of the donor signal, you have to locate that signal booster either close to the indoor antennas or close to the outdoor antennas. Place the indoor antennas away from exterior windows because, again, you don't want your in-building signal leaking out. There is actually an IB wave function that is called IB wave leakage report, and a lot of ASJs are asking for those to make sure that the signal inside of a building does not escape the building as much as possible, right? Do not point any antennas directly at the signal booster. And as I told you, in RF, we want to have kind of like the minimum necessary to work, always have the minimum gain and the lowest power level necessary to maintain a good coverage. This is the two type of deployment. When you have a weak donor signal, what you want to have is your booster close to the donor. When you have a strong donor, you want to have that booster farthest away. Remember, cable typically bring losses into the signal. So if you have a weak signal here, you don't want to have all those losses before it gets to the BDA. So in some instances, you definitely want to have that BDA close to the donor. In the event that you have a lot of signal outside, you have the luxury of moving that BDA to anywhere you want to have it. Again, there is always rules for where you can put the BDA, like survivability rules. You have to be on a 2-hour enclosed place. You have to be near the fire alarm panel. So always keeping that in mind. If you have the chance to put the BDA in multiple locations, make sure that you choose the best location based on how good your signal is, right? This is how, when we have multiple antennas or multiple towers, if you have to have multiple towers, then what you want to have is antennas looking at each individual tower. Again, omnis are not allowed as donors. So if you have these events where your stadium or your hospital has to be covered on multiple, then what you want to have is one donor pointing at each tower to make sure that you have the right service. Yagi's antennas will have this type of Smith chart or antenna reception pattern. So they're very directional. An Omni is typically around, so it receives from everywhere. You definitely want to have antennas that you can point and align to a specific area and receive signal from specific areas. Again, you don't want signal leaking. You don't want to have the path or the signal from the outside and the signal from the inside merge in a large area, because typically what happens, physically speaking, is when you have the signal from the outside and then the signal from the inside. Remember, this signal went through a filter. This signal is lower than this signal. And the radio, when it comes in that merging area, don't know what to do. Who do I pay attention to? Do I pay attention to the BDA or do I pay attention to the macro? And typically, that is going to give you problems when you're using the radio, right? There is a very important consideration, and we do need public safety on tunnels. And tunnels are a different animal, if you will. It's not your typical building. Sometimes on the ground, if you're doing mining, they're going to be vertical or horizontal tunnels. And tunnels are very challenging because stuff within the tunnel, besides the tunnel itself, are going to give you a lot of attenuation, right? So you're going to have longitudinal loss, you're going to have coupling loss, you're going to have incidental loss like the human body, cars, or stuff that if it's a mining tunnel, you're going to have like metal cars, carbon transporting conveyor belts and stuff like that. So tunnels are a little bit of a challenge. There are basically two techniques. You're going to have either directional, pointing at each other, and to cover the whole length of the tunnel. Typically, you can do this with like short tunnels, 1,000 feet, 300 feet, 1,500 probably is your maximum in order for you to do that. And if it's kind of straight, if not, there is a cable that we call leaky coax that basically you're going to be able to run. It's a cable that it's like an antenna. So the cable itself is an antenna. It has a lot of perforations to allow the signal to seep out of the cable. And usually you can cover a larger tunnel with this, right? I just wanted to give you an example of what an ASJ is going to look for in your submittal. You want to have to present like a riser schematic, right? You're going to have your donor signal values, your antenna layout. There is a document that is called the RF link budget that typically tells people what kind of signal are you having and what's the strength of the signal. And that heat map or leakage report is going to be used with this type of reference. As you can see, you're going to see colors, and if you see blue and black, it's kind of bad signal. And this is what the ASJ is going to be looking for. And to finish this off, like I say, I'm part of our what we call our CISA team, so solutions engineers, system architects, solutions architects, and we have done over 2,500 designs that are currently deployed. Right, we have over 50 years of experience. We have a group of product managers and sales and customer support. IB Wave Level 2 certified designers. We typically do about 450 designs per year, and we do pre and post sales support. And what you receive from our designs is a proposed antenna placement, where your cable runs schematics, completely bill of materials, link budget analysis, EMF analysis, inline pricing, stocks, and then you get guys like Tony who are going to help you to with those order and manage the relationship. So with that, turn it over to Tony. If you have any questions, please feel free, and hope you got something out of it.
Thank you, Jeyler. Really appreciate the information as always. It's always a good review for me as well. Some color I want to add to the building owners and end users of these systems that are looking to get their certificate of occupancy. Sometimes this comes up a little later in the process, and they didn't fully understand they need these to get their certificate of occupancy. And they start to look to cut corners, save money any way they can. Something I like to stress with my integrators when working with end users is ultimately this is to not only protect our first responders in the event of an emergency, but this is ultimately to protect us and our children. And sometimes when you put it that way to those end users, it helps smooth over a little bit, trying to get around the cost and trying to cut corners and whatnot and do this the right way. So between Jeyler and I, though, from a technical and sales perspective, any opportunity that comes up, please feel free to reach out to us. We're well versed in all of this and can assist in pretty much any application you can bring our way. So with that, I'll open it up. Are there any questions? All right. Well, Jeyler, you did a great job, buddy.
Yeah,
very nice.
Jeyler,
Very well
thank
done.
you very much. That was very good.
Thank you,
All right.
guys.
Yeah, thank you everyone for joining. If there aren't any other questions, we can definitely connect, people with the folks at Tessco with some questions. And I'll go ahead and share this recording with everyone here later today. But if there's nothing else, thank you again, everyone, for joining, and thank you for the presentation.
Absolutely. I will go ahead and send out contact information to the people on the attendee list. And any questions you have, please throw them over and we'll get on it for you. Thank you all for your time today.
Thanks everyone.
Thank you.
Thank you.
Thank you.